Time for another draftphysics.com video presentation. So, Dean Gosling, it's a reasonable look. Alright, he's made a reasonably polite video, but I'm not going to play it. Alright, he doesn't have the faculties or facilities to play my videos and get my arguments right. And he makes up, he tells me what I thought would happen in an experiment when, no, he didn't ask me what I think happens. Anyway, so he's saying it's somehow on me whether he's going to pursue this or that, and I would rather he just pursue, eating shit and dying, frankly, because, yes, he's not in this in any kind of sincere way. All right, so he's using a spinning disc. Now, we went over all this thing before, that what we're trying to do here, okay, is we're going to put energy into something, and we know the energy is in this little thing. We know it's all in there. All right, and what we're trying to say is how much energy is in there, and we have to figure out a way to extract the energy so we can find out how much is there. So it's like if it was a bunch of photons, well, we could just shoot against the wall and measure how intense the light was and say, okay, there, we know how much energy is there, but it's not. Okay, so it's a little tricky. So I pointed out that Joule is famous, okay, because he went to extraordinary lengths to come up with some kind of way to convert all of the momentum into one thing, one substance in a container. Okay, well, I should draw this as a container. All right, to put it all in a container, all right, pour all the energy into a container and then measure the energy in the container. All right, so, the whole idea was a propeller in water and all that kind of stuff, but the idea is yes, he was going to turn it all into the same stuff, heat, and then he could just measure how much heat this equaled. All right, and so now we're trying to think of some way to take the energy. Now, I've pointed out that obviously the bearing is the only friction that's, all right, we're not going to worry about air resistance. It's a minor amount of stealing of energy. So yes, there's turbulence in the air, and slowly but surely the air will steal the energy, but it's doing it over a really long period of time. If the bearing was perfect, it would spin a very long time from air resistance alone. So we can ignore air resistance, probably agree to ignore it. And so what do we have? We have a spinning wheel, and all we have is this bearing, and that's where the friction is. So we know where the friction is. It's here. So we're not rolling it on the ground, so we don't have that friction, but it's exactly the same friction in the sense the friction is controlled by the weight. Gravity is controlling the friction. The weight is controlling the friction. So the less time something is on top of a surface, the less total weight the surface is absorbing. So when a scale reads 100 pounds, you step on a scale and it reads 100 pounds, it's not telling you it's only 100 pounds. It's telling you you weigh 100 pounds constantly. Okay? Constantly weigh 100 pounds. All right, so it's not just one unit of weight, it's unit of weight over time. And that's the whole total pressure argument. There's a total amount of pressure based on how long you stand on a surface. The surface will endure a certain amount of pressure over a certain amount of time, and that's a certain amount of energy. All right, so you can't change this. So gravity is in this experiment, and because we can't get rid of the bearing, we're stuck with it. So it's going to do something in this experiment, all right? And I've argued that, I've tried, I made this so, I drew it all out, illustrated it all. I mean, what's the failure here to understand? That the simple argument is, and I think the unrefutable argument, the thin ice argument, is that the friction isn't even. So the faster it spins, the less it weighs on the bearing. The less pressure is put on the bearing per unit of surface. Okay, just like on the road, it's less pressure. And that's why thin ice doesn't break if you move fast, is because it's less pressure in a unit of time on the surface. Just a fact. So the friction does something like this kind of a line. All right? It's low friction at high velocity and high friction at low velocity. And that's why you end up going half the speed here and at 3/4 of the distance. And that's why this unit of time is the same as this unit of time and all of that. So we've been over all of that Galilean stuff. And in my opinion, it's irrefutable logic that obviously the bearing isn't taking a constant amount of energy per rotation. So the fast rotations are less energy taken out. The slow rotations are more energy being taken out. So you can't count the rotations and say, there, that's how much energy it is, because every rotation is exactly the same heat. It's not the same heat. The bearing doesn't get just as hot for one rotation very fast as it gets for one rotation very slow, because there's actually more pressure on the bearing per rotation. I really shouldn't have to explain all this, especially explain it over and over and over again. All right. So his claim, and he's asking me this like it's some sort of, like he's an honest player here somewhere. So what he did was, okay, so he has this circumstance. He's conceding, all right, we can't use pressure sources. So applying a constant friction to the wheel is always going to have the same problem as gravity. A constant force won't create a consistent amount of energy coming out, because the faster it goes, the less pressure the sponge or whatever you're using is going to apply per inch of surface. It's actually less pressure per inch. Just a fact. Because the pressure is over a unit of time. All right. So he concedes, okay, let's do it different then. So I suggested that you need some other thing, like you take a piece of credit card or something and you bend it. Okay, so you hit it, cause it to bend, it goes back, and that's a consistent, one would imagine it would be a semi-consistent amount of energy per flip. Now there's some rubbing, there's some pushing, there's some blah blah blah, but that's the idea. And so he tells us that he tried that and it doesn't work with the wheel the way it was. So the mass that the wheel is, it wouldn't work, because if he did anything more than this tiny, barely letting the thing hit it, so it barely hit. So let's say this had 2,000 watts of energy in it, and he was taking out per rotation 1 watt. He said basically he couldn't do it any other thing. It's either 1 watt or 500 watts. He couldn't somehow adjust this thing to take a little bit more, or a little bit more, or a little bit more. It only took one amount, 1 watt or 1,000 watts. Nothing in between. Now we know that's not true. That's silly. So he says it wouldn't spin if he actually used his little straw thing and made it bend the straw more. It didn't work. Now I'm saying that's just dishonest. That's like, obviously I could just 1 millimeter, 1 millimeter, 1 millimeter, 1 millimeter. I could make the units of energy I'm taking bigger and bigger. I go from 1 watt to 2 watts, or 3 watts, or 5 watts, or 15 watts, or 20 watts. I could just make it bend more and take more energy per hit, per action. So this is almost like the bowling example, where you point out that, okay, if you had your 8-pound ball and your 16-pound ball, and you rolled the 16 at half the velocity, the 8 velocity, and you gave this the 16 velocity, what happens when it hits a pin? And obviously the 8-pound ball is going to run out of energy really fast, because when it hits the first pin it hits, it's going to give it this, sorry, I did the wrong way, right? 16-pound 8. This is the 8-16 velocity. So the light ball, the 8-mass ball going 16, the first pin it hits, it's going to give it 16 velocity, right? It's pretty close to it anyway, 15 plus. And what's the 16-pound ball, when it hits, what can it do? It can only give it what it's got, okay? So it can only give it the 8. So yeah, it's losing less per pin to start with. But later on, the 16-pound ball is going to still have lots of energy left, and the 8-pound ball is going to be running out very rapidly. And it's exactly the same argument here. I mean, it's clear that bowlers don't use light bowling balls, even though this is twice the energy here. Okay, so they have no rational explanation for why the bowlers aren't using the lighter ball. Anyway, so, I mean, it just ignores every one of these arguments. It's just so... So anyway, so I find your excuse unbelievable. All right, but I'm all for doing the experiment better. And I would argue that the heavier you make the wheel, okay, in some respects, it's going to help. So he's now taking gigantic weights, really. Compared to the size of the wheel, they're really heavy. So you'd say that just looking at it, it looks like the weight is at least 4 or 5 times. Okay, he's increased the mass by 4 times, maybe 5. All right, so a huge increase in the mass. And so now he's going to rotate, and now he can stick something in there and stop it. Now, I'm not going to say, if he's going to sit there and stick his silly little straw in, that's not going to do anything. The whole point is say if it rolls, say without any interference, just with just the bearing, nothing touching it, it rotates 40 times. The whole point is that's against you, because all those 40, it's gravity controlling, and you can never get rid of that influence. So what you want to have happen is you want to extract the energy as quickly as possible so this curve can't have an effect. So you have to get the energy out quickly before this curve screws up your results. So the whole idea is to get the energy out in much less than 40 turns. If you could make it 4, that would be great, because that means you didn't let the gravity thing take the energy away. You let your thing took it. You want to use you want the device you've chosen to measure the energy with. You want it to get most of the energy. You don't want to leave energy in the wheel to be taken by the amorphous heating of the bearing, because you're not measuring the bearing. You're not measuring the energy the bearing's taking, and besides the fact you're not measuring it, secondly, it's not doing it linearly. It's not taking it in 50-cent chunks. It takes it in too little at the high speed and too much at the low speed kind of thing. It's taking it 50 cents here and 5 cents here. So you're not getting it in rotational chunks. All right, so of course, yes, put your weights on since you've done it. All right, and then use something stiffer, okay, credit cards. You could put 2 credit cards next to each other even, if you wanted something even stiffer. And let it flick across those, okay, and let's see if you can cut the rotations down. Let's say he's getting 80 rotations now. It'd be best if you could just take all the energy in like 15 or 20. That would be better. I mean, like 5 or 6 would be even better, but obviously it gets a little too dramatic then, you know, and you're saying there's some of it you're going to miss just because it won't be able to have enough. It'll have enough energy to turn, but it won't have enough energy to flip the last time. So you don't want it to be too high a denomination, but you want to take it out in big enough chunks that you get the energy out before you do this 80 thing. You don't want to get anywhere near 80, because that means the bearing's doing all the taking. So you want to make sure you're doing it a lot slower. But the point is, he doesn't need these weights. He could have done it the way it was. The way it was spinning 20 times, let's say, at a moderate speed. Now that's not going very fast. That's just so you can see it and you can count it 20 times. All right, and so all you had to do was cut that down to 5. Stick something, a little credit card there, let it hit, and take the energy out in big enough chunks. And yeah, then you're going to measure the energy in equal chunks, and that's the whole point, is to find some mechanism to measure the energy in equal chunks. Okay, something you can add up and count. So again, I'll go back to the original argument about joule. So did you understand the original argument that Joule wouldn't have gone to all that trouble if all he had to do was an Ian Gosling experiment? If this was a really perfect way, if this was really reliable, why wouldn't he have just used this? Why would he have gone to all the trouble to make perfect thermometers, create a room that had the same temperature, same humidity, do all that? Why would he do all of that engineering if this is all he had to do, was make this device? Now, I'm not saying this device isn't useful. It'll give you some kind of vague number. But again, because of the fact that you can't get rid of the bearing and the gravity, you can only reduce its effect. You can't eliminate its effect. It'll always distort the results a little. And obviously, any kind of pushing pressure on the card, obviously you could argue the faster it slides across the card, the less friction that's going to be. So the first few fast motions might be a little bit less energy going into the card to bend it, and the slower it bends it, the more energy it'll be putting into the card. So yeah, you'll get, maybe some will be 45 cents and then some of them will be 50 cents. But that's that's a bad ratio you can live with. That amount of error isn't going to ruin the results. And so obviously my argument's going to be, you spin it twice as fast, you're going to get twice, something close to twice the rotations if you take the energy out with some mechanism that's reasonably linear. And it will prove that twice the velocity is only twice the energy. It's only twice the momentum. And you're exchanging the momentum. You're not exchanging something else. You're taking the momentum that's in this object, and you're either losing it through the bearing, or you're losing it through whatever other mechanism you apply, but you're losing the momentum. You're transferring momentum from this object into these other objects, and you can't make more of it. I mean, again, we've done the 10-ton train, we've done the ballistic pendulum, we've done all these arguments where the frickin' kinetic energy just evaporates, disappears from existence, and he still insists on making these silly arguments when he can't point to a single experiment, okay, not a single car crash, not a single interaction in space, not a single anything to defend this notion that somehow, I mean, I even went to the trouble, the whole gravity thing. If I lifted something up a staircase to get it to 4 times the height, so 4x the height. Now I could launch it at twice the velocity, okay? It'll get there in 2 seconds, okay? Let's say it takes 1 second to go 1 unit of distance. All right, I mean 1 unit this way, of course. All right, so if I went 1 distance and dropped it, or 4 distances and dropped it. All right, so we have a 1 second for this amount of falling, all right, and 2 seconds for this amount of falling, and exactly the opposite for launching. All right, and if I did it this way, up here, 1 unit, so I did this, and then I did that again, and then I did this again, and I did this again. How many seconds am I in the gravity? 4 seconds. 4 seconds versus 2 seconds in the gravity. You really think it's the same amount of energy? That this is the same energy, even though it's only 2 seconds fighting the gravity, and this is 4 full seconds fighting the gravity. I mean, it's 4 seconds plus, right? Because we have the time it takes to launch it again. So we're just talking about the time it takes to lift it. And I could also just do this with falling, right? I could drop it 1 second. I drop it again, 1 second. I drop it again, 1 second. I drop it again, 1 second. So obviously if I could have all those little hits at a nail, I've put in 4 units of 1 second worth of gravity. And if I did it this way, I just dropped it from here and only allowed it to be in the gravity 2 seconds, I would argue the nail's only going to go half as far, because guess what? It's only two units of gravity, 2 seconds versus 4 seconds. So yeah, hammer, 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 hammer is more than hammer, hammer. Yeah. But I just don't, I can't, like I said, there's just no point. You don't really deal with these arguments as they're presented. You don't, so there's just nothing to argue. And again, how can I possibly think you are sincere in stating that, your little plastic straw or whatever, that you only had the choice of barely flicking it or flicking it so much that it stopped the thing from moving? Those couldn't be the only 2 choices. 1 rotation and the thing stops, or 20 rotations. And those are the only 2 choices you had. I gotta call bullshit. Absolute bullshit. All right, so but I really don't care what you do, frankly. Like I said, we've been over this over and over and over again. It's just not my job to debunk sloppy, unthought out experiments with obvious ignoring variables that are real variables, and you just don't want to pay any attention to the variables. You don't want to acknowledge their existence. There's just no point. And you just keep telling me you're proving something. Well, write up the paper and I'll write the counter argument to your paper, okay? because it's nonsense. It's bad physics. It's Chardonnay nonsense. And if you didn't do it over and over and over, I wouldn't have an argument here. But it's every single experiment. You play this game. I'm going to keep fiddling with it till I get it to do what I want it to do. And that's all you're doing. And again, by making your argument, you didn't videotape the straw stopping the wheel from rotating. So until you videotape that for me, that you only have two choices. It rotates 40 times or it stops dead. So until you show me that, I'm just going to say, well, you're just playing games. You're just playing word games. Oh, what do you want me to do? Do you want me to do the experiment? Well, fuck you. Like I said, you don't want to know what I want you to do. You don't want to hear the answer. I think you're a despicable human being. You're just an example of the scum walking this planet. This dishonest, weaselly, connivery, schemery bullshit. You don't even have a good reason to be in this argument. You haven't sincerely had it proven to you. Okay, this whole twice or 4 times or 8 times. You've never seen a gasoline engine use 25 times more fuel to go 5 times as fast. You've never seen that happen in your life. And yet you're playing this game like you're convinced. Ah, bullshit. All right, enough of that. I don't know, maybe I'll throw in some comments just to get rid of them. Because they're just, people are just so obnoxious. The person who has to make 4 comments, okay, and they're all just gibberish. And it's just like, what the fuck? You can't, if you're going to make a comment, make a real comment. Say something. All right, I just deleted a whole comment thread because the asshole makes all these claims about, well, it takes 4 times the energy to do this, and it takes 4 times the... And none of it's proven. There's not a single experiment. The whole point of me making the video is to point out nobody's done the experiment. We can't show the videotape of the 4 pounds dropped 1 foot and the 1 pound dropped 4 feet. And we have this decisive experiment that proves the case. What we do have is, right, the Falwell crap where the frickin' spring moves 1 centimeter. The spring this big and it moves 1 centimeter. Oh, too pathetic. Alright, so anyway, I'll read this shit from some monkey shit. Anyway, you ended up with twice the velocity and 4 times the energy over 4 times the distance. So again, where? What are you talking about? I mean, it's just so fucking stupid. Alright, and 2 times the time by your own logic. No, there was no my logic that said any such thing. What my logic pointed out is that there's just no way you can destroy something called energy. And so you have to conserve one or the other. You have to pick one, okay? Because 1/2 mv squared, every single time you do an experiment where you're going to have 2 things of unequal masses interact, you have to destroy momentum or you have to destroy kinetic energy. You really don't have any choices. You can't conserve both. It's ridiculous. Okay, and then he says some integral, the force dt. I see no problem with this and the v squared formula because you're an idiot. Okay, so I shouldn't even acknowledge comments that don't say anything, they don't quote anything. It's just such nonsense. Constant force over time means constant acceleration over time. No, it doesn't. So again, it's just more bullshit. That's only for something free falling. All right, so that doesn't mean anything. You can apply constant forces to things that aren't moving. That gives you the linear relationship of velocity, but constant force over distance gets you different relation, namely 1/2 mv squared, blah, 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 blah. And again, it's a time-dependent force, so you have to provide some sort of evidence, okay, that each one of these units of distance, it gained 9.8 meters of velocity when it didn't. It's only in the gravity twice as long, and it only has twice the velocity, so how could it gain 4 units of energy? How could it be 4 units of energy when it was only in the gravity for 2 units of time? Again, this is back to the scale argument. You put one unit of mass on the scale, it weighs, and then you put a same unit on the scale, and now it's 4 times the energy. It's only twice the weight. How can it be 4 times the energy? All right, what you said here is perfectly fine if you're talking about what I said here. It's a whole video. I just hate these people that do this bullshit of commenting as they listen to a video. Just hate it. All right, anyway. Changing momentum as work, but work is changing energy. I'm sorry, it's just absolutely silly. There's no example you can provide where you can ever do any work without using something's momentum. You have to consume momentum to do work. It's impossible to do anything else, so it's just lies and bullshit. All right, if potential energy is mgh, and I'm arguing it isn't, and you go 4 times higher, you get twice the speed. Right, twice the speed instead of 4 times the speed. So that should be telling you something. Oh, it's only twice the speed. Why the fuck would I think twice the speed is 4 times the energy? That necessarily means you must have v squared in the kinetic energy formula with 100% certainty. Based on what experiment? So again, just nothing from these assholes. Simply because that is the relationship that proves it's 4 times the increase. Just look at all this. I'm not reading all this slop. What is this? Where did you fucking type this from? Where did you cut and paste this crap from? Oh, amazing. This asshole thinks I'm going to sit there and read all that mush. Make a video. Too ridiculous. All right, see, I don't mean to scorn you. I have every intention of insulting you as deeply as I possibly can, you piece of Weasley scum. The whole fucking point is you've had 350 fucking years to show me a 5 mass going 10 velocity and a 10 mass going 5 velocity in a tug of war, and show me the 5 mass winning decisively. 350 fucking years and you can't do the experiment. All right, you don't have to buy into my arguments. Yeah, I'm certainly not, if you don't want to. Yeah, that's right. But what are you talking sounds like a conflation of what work means with an integral of change in momentum over time. So again, where's the momentum changing? So again, this is, what are you talking about? With respect to just the upward force on an object, which is how heavy it feels. I mean, you're not going to pay any attention to what's in the actual videos, right? You're just going to type this shit. All right. Heavy it feels, lift an object, how much delta V a rocket would need to carry an object, but those are not. Yeah, again, you don't have any evidence that any of that is true. I mean, I can do the gun example. I mean, you fucking cunt. So I take a gun and I put another gun inside. So I take a 45 and I put a 38 inside of it. So there's 2 guns. And I put the same charge of a bullet in there, and I fire it, and the 2 guns fly apart. Well, momentum says I have 2 joules here, and I have 2 joules here. All right, now I put a zip gun. All right, so the explosion only made 4 joules of energy. All right, now I take the same exact charge, and this time I put in a zip gun. So now I have a gun open at both ends, and I put 2 bullets in, just 1 charge though. And I fire the charge, and I get 2 bullets with 2,000 joules and 2,000 joules. So now I have 4,000 joules. So the same explosion made 4,000 joules, and in another case, the same explosion makes 4 joules. So I can just make up any number for how much power a rocket has. I can say anything. You know, if you ever actually look up when they talk about how much dynamite thermonuclear device has, you know, how much how many megatons, they'll admit it's all made up. They don't really know how much energy it is. They're just making it up. You people are just pathetic. But these are not necessarily synonymous, and that's not what is meant by work. So again, fuck you. I mean, really. I've already gone over it so many fucking times. You don't have any rational definition of work. You're telling me that if I hold 100 pounds up against gravity and I hold it steady, I'm not doing any work. Bullshit. Ridiculous theory. Personally, I think work is a trash word, but that is a different discussion. The word isn't trash. The formula is trash. Doing work is kind of silly. No, I mean, exchanging your energy is what work is. You're just converting it, just changing it. The Newton's cradle does work. It takes the ball going this way and it makes the ball at the end go that way. It's exchanging. All right. Doing work is kind of silly because there is only even transference of energy. while the system transforms. What is this? Parametrically, while the system transforms. Yeah, so is that another way to say it? You have to conserve? Well, you can't conserve. So the ballistic pendulum, the 2,000 joules of energy goes into the ballistic pendulum and turns into 2 joules. You lose 99.94% of the kinetic energy, disappears, yet you conserve 97 or 8% of the momentum. So where are the 999 joule, the 1,999 joules of energy? And if you're going to say, well, it's heat or it's something, then I'm going to say, well, how could you conserve 98% of the momentum and create 2,000 joules worth of heat? You can't conserve momentum and make other stuff move. That's not possible. So you're all full of shit. I don't even know what to do with these comments. I just can't even believe he would type all this shit. I guess I will read it, but not today. Oh, just amazing. Amazing. Jesus Christ. People are nuts. 4 comments, and one of them is all of this abstract shit. But what if there's 4 people on a train, and one of them's sitting backwards, and one of them weighs 400 pounds, and one of them weighs 50 pounds, and one of them's wearing a blue shirt? How many are drinking Gatorade? I don't know. I have to think about it. Oh, I just hate this planet. Fuck nuts. Okay, anyway. Till the next time and such and so forth and whatnot. I just hate it here. Hate it here.